Hello everyone, my name is Vishal Masih from St. Francis World School, and the topic that we have selected today, that is construction for class 6, and the agenda of the topic that we are going to discuss today, that is perpendicular bisector. What is it? Drawing a perpendicular from a point given on a line. Draw a perpendicular from a point which is given outside a line. Then angle bisector, what it is? Drawing a line which is parallel to other line, and the construction of all these basic angles 60, 30, 120, 150, 90, 45, 75, 135, 15 and 22 and a half degree. So let's start the topic, and we hope that we could cover all these topics. So let's begin. So let's put for heading first, which is construction. So first thing first, that is perpendicular bisector. What is the meaning of perpendicular bisector? Suppose two lines make an angle 90 degree. So as I said lines, so I need to draw arrowheads on both the sides. Then say this is point O, A, B. Bisector means OA is equals to OB, and this line MN and AB are mutually perpendicular, means the angle between them is 90 degree. That means angle MOA is equals to 90 degree is equals to angle MOB. So in that case, we can say these two lines are perpendicular to each other, and line AB is bisected by line MN in two equal halves, where OA is equals to OB. So let's start with the construction, how to construct. But the basic idea for construction is when we use only a ruler and compass. So construction means making an angle or making lines in such a way where we are using only compass and pair of compasses and one ruler. Yes, of course, a pencil. So suppose we have been asked to draw a perpendicular bisector. So let's just take a line here. Let's assume this is a line. When I'm saying a line, so I'm not drawing arrowheads. So we are just assuming a line segment to which I'm calling a line. So place a compass on one of its end and fill a distance. This is basically a radius that we have taken, which has to be more than half of this length of this line, and draw an arc and repeat the process from the other end of the line. Then, without changing the radius, mark another arc, and now what do we have to do is just drawing a line which is perpendicular to this line. See, this is so the angle between this is 90 degree. The angle between these two lines is 90 degree. This angle is 90 degree, and this is A, B, O. So here AO is equals to MBO. And if this point is M, so we can say angle MOA is equals to 90 degree equals to angle MOB. So these two parts are equal and the angle between these two lines is 90 degrees. So this is called a perpendicular bisector. Let's move further with another construction, which is drawing a perpendicular from a point which is given on the line. So suppose this is the line and here we have been given a point anywhere on the line. Let's say this is the point, and now take this compass, just reduce the radius, put it on the point now, and then make an arc, and the arc is in the form of a semicircle. So we have chosen a radius here, but we do not have to choose another radius. Now here is a point of intersection, then place the place the center of this compass on this point of intersection and then make another arc, then repeat the process from the other end and then mark it again from the other end. Then now we have two more point of intersections. In that case, just let the radius be same and use two same points of intersections and mark an arc again here. So by using these two points of intersection, we have marked two arcs again without changing the radius, and in that case we get a common point of intersection. This is what we require to draw a line. Now we can say that we have 2 points now, one is this and one is this point of intersection, and by joining these 2 points we get our perpendicular, which is drawn from this point which was given on the line. This is 90 degree. So if this is A, this is O and this is M, so angle MOA is equals to 90 degree. Obviously if this point is B, so angle MOB is also 90 degree. So this is the construction for uh, for a line which is perpendicular to a given line, but from a particular point. Now let's move further for the next construction, which is, now we have to draw another construction which is for a perpendicular line, but the point is given outside the line. This time we have been given a point outside the line. Suppose this is the point, and from this point we have to construct a perpendicular on this line. So how do we do it? Now again use this compass, put the center of this compass on this point, and now just widen this angle, the radius, sorry, and just mark an arc using this radius. So yes, we have done it. Now I have reduced it. I need to redraw this because we cannot change the radius. So yes, now mark an arc And now we have got 2 points of intersection. One is this and one is this. Use the same point of intersection and mark an arc. Now place it on the other end, other point of intersection, and mark this arc. Now we have got a common point of intersection by using these 2 point of intersections without changing the radius. Now what do we have to do? The same thing that we did. Just we have to draw a line using these 2 points, which is perpendicular to this given line here. So yes, this is 90-degree angle. Suppose this is a point M, this is O, this point is A, and this point is B. So here angle MOA equals to angle MOB, which is 90-degree. So we can say we have drawn a perpendicular from this given point, which was given outside this line, to this line. The perpendicular is MOA or MOB. So let's move on to the next construction, which is drawing a line which is parallel to a given line. Suppose we have been given a line here. This is a line, let's say AB, and we have to draw a line which is parallel to this line AB. So how do we do that? Let's take a point. Let's take a point outside this line. Suppose this point is P. Now draw a slant line using this point P, this. So this line we have drawn, that is point P, that is this point is M. So PM, which is inclined to this line AB. Now what do we have to do? Just use compass here. Take a suitable radius and mark an arc. Again, use this compass, but on the point that we had taken deliberately, and mark another arc with the same radius. Now what do we have to do? We just have to measure this angle. So use this compass, and this time, the very first time, we are going to adjust the radius of this for the sake of our construction. So this here, this is going to be here. Here, this point of intersection we needed, but actually what we needed is the angle between these two lines. So the same we are going to do here. We have drawn this arc using the previous radius. Now this point of intersection is to be used. This point of intersection is to be used to mark the same arc that we have just marked by using the same radius. Here we go. This is the point of intersection that we were looking for. Now what do we have to do? Just use these 2 points and join them. here. This is, voila, this is a line which is parallel to this line AB. Suppose this is M, this is N. So here, now let's name it like a line so that I can show that line AB is parallel to line MN. That's how we can represent it in mathematical form. So line AB parallel to MN. I hope it is clear. So let's start the next construction. Move on to the next construction, which is angle bisector. Which is angle bisector. So what do we understand by the word angle bisector? Angle bisector. Suppose we have drawn an angle. We have drawn an angle. I'm just giving this idea. We have drawn an angle, any angle. And if I bisect it in two parts, which means if I construct a ray in such a way that this angle is equals to this angle, then I can say this angle, let's name it. And the important thing is, for angles we always use rays. Why rays? Because one end is fixed and one end is not fixed, so this is a ray. And how do we denote a ray? Let's say OA is a ray. So A has arrowhead but O does not have the arrowhead, so that's why we denote it like OA, and a arrow pointing to with arrowhead pointing towards A. So that's how we denote a ray. So ray OA and ray OB are two rays which have a common vertex, which is O. So when an angle is formed, when there is a common vertex between two rays, like OA and OB has a common vertex, then we can say an angle is formed. And if I say this is point M, then I can say angle MOA is equals to angle MOB. Then we can say that this angle AOB is divided into two equal parts, which is MOA and MOB. Then we can say angle AOB is equals to twice of angle MOA or twice of angle MOB. This is the definition of angle bisector, or we can write it in such a way like angle MOA is half of angle AOB. This sounds more perfect. Angle MOB is half of angle AOB. So let's learn how to do it. Let's draw a ray first. So this is a ray that I'm using. Now use compass, and the same idea that once a radius is chosen is not to be altered again and again. So a suitable radius I have taken, just mark an arc with the radius. Now here we get an arc. And one more thing I have forgot to mention here is that I did not take us did not take an angle. So just make an angle. Yes. So I had taken a radius. This is the angle. This was a suitable radius that I have chosen. Now using the same radius and by using these two points of intersection, I have to draw arcs. I have to mark arcs again. One arc from this point and one arc from this point. So this is a common point of intersection that we have to use, and now by joining these two points, yes, just by joining these two points we get an angle bisector. So suppose this is A, this is O, this is B, this is M. So we just saw that this angle was 25 degree. This angle was 25 degree. So if this is 25 degree, so this has to be 25 degree. And this complete angle would be 50 degree. And we can write angle AOM is equals to half of angle AOB, which is nothing but equals to angle BOM also. So that's how we bisect an angle which was AOB, and that too of 50 degree. If we want, we can measure this. See, this is a little bit adjustment. So this is almost 50 degree. Just a minute correction, just because of the points that we are using here are thick, so that's why there is a little bit mismatch, just because of those we can say coarse strokes of line, so that's why a little bit difference is there. Otherwise 50 degree angle is bisected in two equal halves, which is 25 each. So this is all about angle bisector. Now we are coming to our topic, which is construction of basic angles. So let's move further. So suppose we have to construct an angle which is 60 degree. So how do we do that? So the first thing is just draw a line, use compass and a suitable radius. Now by using a suitable radius, just mark an arc. We get a point of intersection here, and now again use this compass, put the center of this compass on this point of intersection and mark another arc by cutting the previous arc, and now just join these two points of intersection and see the perfect line and the angle it is showing, which is 60 degree. This is 60 degree angle. That's how we can construct a 60 degree angle. Now the next angle is 30 degree. How do we do that? So two lines that we are going to use is, just understand this thing. This is A, this is O, this is B. AOB. Angle AOB is 60 degree. Now I am going to use these 2 points of intersection. One is this is 0 degree, and one is 60 degree, and I have to just bisect it. So how I am going to do it? Just add them and divide it by 2. So one time the compass will be placed here, another time it will be placed here. So 0 plus 60 is equals to 60 degree divided by 2, and what do we get is 30 degree. So place our compass using the same radius without altering it. So just mark the same arc here and use this, and now just mark this arc. Now let's join this common point of intersection, which is giving us an angle bisector of 60 degree. See, the perfect angle bisector of 60 degree, which is 30 degree. So again, we have drawn an angle bisector of 60 degree. We have constructed. So we constructed 60 degree, 30 degree. Now how do we do for 15 degree? So this time we can draw an angle bisector of 30 degree. Just mark the same arc using the same radius here, and now use 30 degree line, and then this, and this time it has to be 15 degree because 0 plus 30 is 15 here. A perfect angle bisector of angle 30 degree, which is 15 degree. So that's how we have constructed 3 angles. One is 60 degree, another is 30 degree. So this MOA angle MOB is 30 degree, and this angle NOB is 15 degree. So we constructed 3 angles. Let's move further. Now let's draw an angle which is 120 degree. So first of all, draw a line, use compass, place it on one of the vertex, and then use the same radius, mark an arc. Now mark another arc. This is 60 degree. Now use this point of intersection and mark another arc which is 120 degree. Now use this compass, use this scale, and just join these two vertices here, and here we get an angle of 120 degree. Now if we want to construct an angle which is 150 degree, how do we do that? So let's increase this line in the opposite direction, and then this was 120 degree, and now we are switching our construction to 150 degree. So 120 degree, and then use the same radius here, then mark this arc. Now how do we get 150 degree? So the difference between 180 degree and 120 degree is 60 degree. And if I add 120 60 degree to 120 degree, no, if I add 30 degree to 120 degree, what do I get? That is 150 degree. So how do I get this 30 degree? The idea is simple, that angle bisector of this 60, which is 30 degree, and add it into 120 degree. And how do I get this? I have this 60 degree angle. Now I am going to use the same radius here, mark this arc, use this point of intersection and mark this arc, and now using this compass I am getting this 150 degree. Here, oops, here, this is the line, the perfect 150 degree angle. This is 150 degree angle. Suppose I want to construct an angle which is 90 degree. Then how do I do that? So let's move further. For our next angle, just wait. So just draw one line, a horizontal line. Now for 90 degree, put compass on one of the ends, then mark an arc by using a suitable radius. Then first thing is to mark 60 degree arc. That's done. Then mark 120 degree arc. Now let's understand a little bit maths behind 90 degree angle. I have 120 degree angle and I have 60 degree angle. But the difference between 120 and 60 degree is 60 degree. And how do I get 90 degree? If I add 30 degree to 90 degree. Sorry, if I add 30 degree to 60 degree, I get 90 degree. I have 60 degree arc. Yes, I have. But I do not have this additional 30 degree. How do I get this? I will be getting this by the angle bisector of this 60 degree. Where is this angle? Let me show you where is this angle. So let's draw these angles first. So this is 60 degree and this is 120 degree. Here. Now I hope you can see this 60 degree angle I was talking about. So this is 60. Now additional 30 degree. So from this angle we are going to get this. So now just make an angle bisector of this. So for angle bisector, how do we do that? 60 degree plus 120 degree divided by 2, which is 180 degree divided by 2, that is 90 degree. So one arc from 60 degree, that I had already marked this arc as a larger one. So I use this point of intersection for marking this arc which was larger. Now I'll be using, so let me sign it again. So let's go to our work again. Here. But the problem this time is that now we need to adjust this radius. No problem. Let's do it. Let me adjust the radius again. Done. So now just make an angle bisector. So this arc I had already made. Now I'm putting my compass center of the compass here on this 120-degree angle, and I'll be cutting this arc. Voila. Now we have got this common vertex. So by using this vertex, I am going to make an angle which is 90-degree. Let's check whether we have got the angle or not. Here it is, a perfect 90-degree angle. This is 90-degree angle. But what if we have been asked to draw an angle of 75-degree? How do we get 75-degree angle? Now the idea is same again. 60-degree. Let me move this compass and let me erase some portion from here. All right. So 60-degree plus 90-degree by 2. What do we get? 150-degree by 2, which is 75-degree. So this time what I am going to use, point of intersection of 60-degree and 90-degree. So let's use point of intersection of 60-degree and 90-degree. This arc I had already made using this 60-degree. Now I am going to use this point of intersection on 90-degree angle, which is this arc, without changing the radius. Now let's make an angle of 75-degree. Here it is. So this is a perfect 75-degree angle. How do I get 45-degree angle? So 0 plus 90 by 2. 0 plus 90 by 2 is 45-degree. 90 by 2 is 45. So now use 90-degree arc from 90-degree vertex and 60-degree vertex. 60-degree 0-degree vertex. So point of intersection on 0-degree line. So that was the 60-degree arc, and one from this 90-degree. So this is what we have got from 90-degree here. A perfect 45-degree angle. And what if we want to construct 22.5-degree? So consider that as an homework, because further you have to just draw the angle bisector of this 45-degree. So that's all for today, and here I conclude my topic. So this was all about constructions at for 6th grade. At this level, this all is the type of construction of angles and the basics of construction that we were required to learn about. And that's it for today. So thank you so much. This is Vishal Masih signing off. Thank you.